Hey everybody, if you've just finished the quantum numbers video, you may have some nightmares about this screen, right? So there's a lot of stuff going on here. But what I'd like you to do is jump in your note guide to page 12, and what you'll find there is our discussion of orbitals. And so orbitals are these regions of space where we're likely to find electrons, and on the lower left side of the Orbitals Note Guide, you'll see a table. And so if you're not there yet, pause the video, get there, because it's going to make a lot more sense if you have that table. Once you have that table pulled out, I want you to notice how when we generated all of these numbers, it corresponds to that table. So I think the video that we're going to look at today is going to make a lot more sense of all this quantum number stuff and how it correlates to something you might actually be able to picture in your head. So I'm actually just going to join you on the note guide for this video. Let's discuss. And so again, when we think of orbitals, orbitals are these regions of space where we expect to find electrons. So let's first talk about different shapes of different orbitals. So remember these letters, these corresponded to L. Remember, if L was equal to 0, that was an s orbital. If L was equal to 1, that was a p orbital. L equal to 2, that's a d orbital. L equal to 3, that's an f orbital, right? So we corresponded those to these quantum numbers. But today is all about trying to conceptualize what those orbitals actually mean. So for an s orbital, S is a spherical shape. These look two-dimensional, so they just look like circles, but picture these as spheres. And you'll notice the difference between things in the 1s, 2s, and 3s. So remember that every single energy level has s orbitals. In the first energy level, there's s orbitals. In the second energy level, there's s orbitals. In the third, etc., all the way down the line. And you'll notice what is different between those energy levels? Well, they get bigger. So the second energy level is larger in size. The third energy level is larger still. The fourth is larger still. Looking at p orbitals also have a shape. These p orbitals are shaped like a peanut, for lack of a better term. Just so you know, these are likely the 2p orbitals. If I wanted to draw in the 3p orbitals, they would be, no surprise here, bigger. So same shape, but bigger orbitals if we were drawing in the 3p orbitals. So let me erase those, and let's notice something, right? So there are 3 different orientations for p orbitals. They can be along the x-axis, the y-axis, or the z-axis. And so if you're kind of playing around here, check out the number of orientations and shape column and notice how it goes up by odd numbers. So we go from 1 to 3, and it's no surprise then, for D, we have 5 shapes. Another way of thinking of d orbitals, in most cases, they look like a double peanut, right? So you have 2 peanuts in one, except this one down here is craziness. So that is a special kind of d orbital, but you'll notice there are 5 different shapes. And as we go down to f orbitals, there are 7 varieties, and look at how they get even crazier still. And if we went on to g and h and I orbitals, they would get even more and more crazy. But the kind of point of showing us these different orbitals on this note guide is to understand that the different orbitals have different shapes, and the number of different orbitals corresponds with, so these values, the number of different orbitals goes up as this letter goes up, and remember that letter is equal to a quantum number. The quantum number is L. And so as we went up from L equals 0 to L equals 1 to L equals 2, that increased our number of shapes. And we also then did M sub L, right? So if we just kind of think through what's going on here as best we can, the energy level is given on the side. Let me write in the energy level. So here's our energy level. First energy level, second energy level, third energy level, fourth energy level. Let's put L in red. So L, let me rewrite that L. L is our quantum number that helps us to figure out the shape that we see. And so L here is equal to 0 for s orbitals, it's equal to 1 for p orbitals, it's equal to 2 for d orbitals, and it's equal to 3 for f orbitals. And remember, L always has a value that is equal to n minus 1. And so if it's n minus 1, that works well with what we have, because notice the blue numbers on the left-hand side, L is always one number less than that. And then the next thing we did was M sub L. So let's make M sub L, I don't know, purple. M sub L corresponds with a number of orientations. And so we said for spherical things, there's only one orientation. So we just have this 0 orbital, because whatever way you spin that, it always looks the same. For P, there are 3 orientations, right? So M sub L could equal -1, 0, and 1. There are your 3 numbers. For D, there are 5 orientations: -2, -1, 0, 1, and 2, right? And so that corresponds with 5 shapes. For F, there are 7. We have -3, -2, -1, 0, 1, 2, and 3. And you'll notice that those purple numbers range in scale from the value of L from its positive side to its negative side. And then the last thing we're saying is that in every single one of those orbitals, we can hold 2 electrons. We can hold one going up, and we can hold one going down. And so the place where things really expand is illustrated well down on this table, right? So the quantum number, we have written this column above in blue. The number of shapes we have shown in red, but here's the thing. Notice that in the first energy level, there's only one shape. There's just S. In the second energy level, there's an S and there's a P. In the third energy level, there's an S, a P, and a D. In the fourth energy level, there's an S, P, D, and F. So it's not just, let's take the second energy level, for instance. In the second energy level, it's not just these 3 orbitals. It's those 3 plus this 1. And if we went on to the third energy level, it's this 1 plus these 3 plus this 5. So you keep adding on every time you go to another energy level. And that gives rise to what we see in the table in the third column. So notice the third column tells you the number of shapes. So that's what we've done here in purple. This is purple, right? And you'll notice every time we have an S orbital, there's one shape. Every time there's an S orbital, there's one shape, one shape. Every time there's a P, there are 3 shapes. Every time there's a D, there are 5 shapes. And so that tells you, first off, how many total orbitals. And remember, we're adding these up. So like in the third energy level, it's not just the S orbital. It's not just the P orbitals. It's not just the D orbitals. We add all of those together. So that's why I have 9 total orbitals. We have the 5 from the D sublevel, we have the 3 from the P sublevel, and the 1 from the S sublevel. All comes together to give you 9. Remember that every orbital can hold 2 electrons. So if you have 1 orbital, 2 electrons. 3 orbitals, 6 electrons. 5 orbitals, 10 electrons. And if you add all of these up, you get the total number of electrons, which is just this number, this 9, times 2. Okay, so let's get some practice problems doing this. So number 1 says, how does an electron in a 3s orbital differ from a 1s orbital? Not very much, other than the one in the 3s is higher energy. And if we were to sketch these in, 1s might look like this, whereas 3s might look like this. So another thing we could describe about those electrons is the one in the 3s orbital has a wider volume to occupy. There's a wider area where we might expect to find that electron. Number 2, how's a 3p orbital different from a 2p orbital? Well, again, that's very similar to what we just discussed. If we draw in, let's say, a 2p orbital like this, peanut shaped, and I just decided to put the one on the x-axis. You could have drawn one vertically or going into and out of the page. If this were my 2p orbital, then this might be my 3p orbital. And so in response to the question, the answer is the 3p is bigger or larger. And finally, number 3, how many sp, d, and f orbitals exist? Well, this is kind of a trick question. So first off, if we just take this at face value, the answer to this is infinite. Why is that? Because n, the number of energy levels, is infinite, right? So if n is infinite, if we have infinite number of energy levels, that means we have infinite number of orbitals that exist, right? But that's probably not what we're interested in this question. So how many sp, d, and f orbitals actually exist? Well, that's more looking for this, right? We said that in the s, we have one shape. We just have that 0 shape. So there's only one type of s orbital. In P, we have -1, 0, and 1. So there are 3 shapes. In D, we have -2, -1, 0, 1, and 2. So we have 5 shapes. And let's switch colors here for F. In F, we have -3, -2, -1, 0, 1, 2, and 3. So we have a grand total of 7 shapes for an F orbital. Hopefully this made things make a little bit more sense with regard to orbitals and quantum numbers. Again, work in progress, something that we need to keep chipping away at, getting practice with, and that may come a bit more as we start doing something called electron configurations here